So I'm going to quickly go over data tables, and really they're very powerful and not necessarily something that people know exists within Excel. We're going to use them throughout the entire course. So this is a built-in data table. We're also going to use solver table in a future chapter. It's very similar in how you're doing it. So you really need to be familiar with these, and that's why instead of me lecturing in class, I'm going to have this video so you can always go back and watch it. So make sure that you understand the purpose of a data table before you move forward. Using an in-class example, so the Chapter 2 example, page 1 of the spreadsheet, the t-shirt sales, there's the questions that I had within the quiz, and it was things like, change demand to this, what's the profit? Change the order quantity to this, and be sure to change demand back. Change the demand and the order quantity. There were a lot of different things. You're changing the variable cost. And all these things, you always had to reset it to the original variables. What you're doing there is a sensitivity analysis. You're seeing how a change in a variable changes the profit within the model. So and that's the literal example for this one. You may be running a sensitivity analysis on any number of things. Within this example, we're seeing how the change in the variables, the inputs, affects the profit. So thinking this through, how do you present your results? If you wanted to show someone all of the different values for profit based on all of the changes in variables, what could you do? Well, you can have your model and you can copy it to a different tab. You might have 55 different tabs with all the different variations. You can copy it, so move things around. You can keep track of the results somewhere else. There are a lot of different things. But what if you've copied your model from tab to tab to tab to tab and you find out that there's a fundamental flaw? Maybe we know for sure that one of the inputs has changed. Well, then you have to go back and change every single tab, every single instance of it. So what if you could have the original model and test the sensitivity? And that's what we're looking for here. So it's sensitivity analysis. How does a change in variables affect an aspect of the model? In this example, it will be the profit. We have one input, we could have two inputs, we have multiple inputs if we're doing a one-way table. But really, we're trying to figure out how decision variables change, how the objective changes. And again, in this example, it's going to be profit. So it's useful for anything that fluctuates in variables. And you'll see this, again, we're doing this the entire term. That's why I'm making a video and posting it on D2L, so you can always come back to this. You really have to understand it. Because within the questions, it will say things like, if the price of whatever goes up, whatever percent, what does that mean to profit? So prices, rates, demands, all those things. How will the changes in variables affect the end result? We may find that the input's value doesn't even really matter in the solution. It might be something where a raw material within the final product, the change in price for it doesn't really affect the profit. And it may be that we come up with something else. So again, sensitivity analysis, how sensitive is the model to a variable or variables? Different textbooks, different companies, different organizations use different tools. You may be working somewhere where they have a specific tool where you put a data model together in Excel, press a button, and poof, it tells you which variable has most impact on the data model. Within this class, I'm keeping it as Excel as possible. And this is built into Excel. There's no third-party software here. One-way and two-way data tables come right within Excel. We're going to use solver table a little bit, and that's something that the author wrote. But again, it's really using built-in Excel stuff, and it's free. So again, this whole concept of the sensitivity analysis, the one-way, two-way data tables, is very important moving forward. So if you are doing a data table and you are manually calculating each step along the way, you're not doing it right. This is supposed to make your life easier. That's a lot of what we're doing in this class, is trying to make your data models more efficient and showing you easier ways of calculating things and coming up with a best case scenario. So if you are not sure what's going on within this, even watching this video, go back to the Excel tutorial, read through Chapter 2, Google it. We're using out-of-the-box Excel. There is nothing magical about what I'm teaching you. It is all out there. There are probably hundreds of YouTube videos explaining data tables. It is worth your time to make sure that you understand this, because the course is cumulative, and if you don't know what a data table is now, you're running out of time to get caught up. So now's the time to understand what's happening. So I'm going to use the t-shirt sales as an example. I know you all have it, so I'm going to run through it. I'm going to do a one-way table, maybe a two-way table, and I'm going to do a little bit of goal seek as well. So this is the NCAA t-shirts. It's example 1 from chapter 2, and I'll get rid of the comment within here. And again, this is what we're looking for in a data model. It's all color-coded. The inputs are in one spot. Decision variables are in another spot. And there's no perfect place of putting these. You can have it on another tab. I'm just going to do it right here. So let's say I want to see how a change in fixed order cost changes the profit. And this is a fairly straightforward, and again, this is a simple example. So if I were to tell you I want to see how profit changes to, if the fixed cost is 700, 725, 775, and 800, you can obviously go through and subtract 50 from this, and you know the answer. I'm giving you a simple example so that you can see how it works within the model. So it's the simplicity of this makes it easier. If you can do it in your head, you can see how the model is going to, how the data table is going to help within your model. So setting up the data table, I have the various inputs here. I want to try these 4 inputs, replacing this, but I want to keep the original model intact. I refer back to the profit. I can choose any part along here that I want to, but I want to see how it changes profit. Select it like this, and then data table. What if analysis, data table, and you have to put in the cell that matches, and we're only doing one variable here, and these are columns. If you're trying to think through what's a row, what's a column, the Roman columns, if you think about the Colosseum or whatever it might be, the things that are holding up the structure, that is the column. So the column is always this way, the row is this way. So we're replacing the variable within the model with these. So the column input cell will be here. And we find out, as expected, when we drop our fixed cost by $50, the profit goes up by $50. By 25, it goes up all the way through. We have what we expect here. That is about as simple as a one-way table I can possibly give you. I'm going to do another one here. So if we were to do variable costs for the shirts themselves, so let's say we can negotiate with the supplier for these, and I'll put the original in here. 0.25, that's enough. And I'm not leaving room for my initial profit here. There we go. So equals, and I want to find out how it changes profit. What if analysis, data table, I am changing the column, so the column here, and I want variable cost. And what did I do wrong? Oh, it didn't update. I didn't do anything wrong. I must have calculations turned off on here. So there it is, that's how it changes. So if the variable cost changes, so 13,750 is our initial. Make that a little easier to read. So 13,750 is our original, the $8 variable. That's right in here. If we can get that down to 750, we can see that our profit goes up 14,475. And let's go ahead and we can see by dropping the variable cost to $7.50, we earn an additional $725. If it goes up, this doesn't look right, does it? Oh, look what I did. I didn't use my absolute reference. Oh, that's nice. This is good. This is good learning for you. If you forget to set these things, it doesn't work right. There we go. So again, I had to set the absolute value so it doesn't change, and you can see that I'm using this value here minus this value here, the original model. So it's by locking it in, and this one is the same, of course. So if the variable price goes up, the variable cost goes up, we would be losing $362.50. If we can get it to drop from 8 to 775, we add another $362.50. And then of course every quarter, so it's every 25 cents, it's $362.50. This is linear. We can map this. We know for every 25 cents it'll drop this much. So this is one-way data tables. We can also do two-way, and this over here because I want to see this, and I'll do this, and this is a nice little trick. I don't think this shows up in the book. Why isn't it letting me do it? Come on. Copy. And paste special. So I'm going to transpose. I'm copying from a column to a row. There. Two-way data table is a little different. I have to have the profit formula here, or what it is that I'm testing. Select all of it. Data table. So I now have two inputs. My row input is going to be the variable cost. The column input is fixed order cost. There we go. So we can see a combination of the fixed order cost dropping to 700 and the variable cost going to 750. We can see what the profit would end up being. If we end up having a lot of details in here, we can actually use the max function and see that the highest number is 14,525. That's this one here. No surprise. I mean, really, this is so simple. No surprise. When you have the lowest cost, you have the highest profit. And I'm just showing you with a very, very simple example. And I'll go ahead and do a quick goal seek as well, just to see how that would work. And what we do with this one, let's say we want to get the profit to 14,000 by changing the selling price. So let's say we want to make 14,000 off of this whole deal. What selling price, given these inputs, would reach 14,000? So what if analysis, goal seek? So we want to set the cell profit 14,000 by changing the selling price. We have an answer there, and this is, we need to get a couple more decimals in here to see it. Nope, wrong one, that one. So if we were to charge $18.17 per shirt, we would end up getting a profit of 14,000 given all of these inputs. So again, I went over these very quickly. This is a 12-minute video showing you something that is a bit more complex than I have. This is the simplest model in the textbook we could possibly do a data table. I assure you it will get far more complex from this. If you have no idea what I just did here, how it all works together, you'll have a hard time moving forward. So make sure that you understand the concept of the data table. Again, Google it, YouTube it, read the book, ask me questions, go through the tutorial. Make sure that you understand this very simple sensitivity analysis and goal seek, because we'll be doing far more complex as we move forward.